was in your note packet, and this is on page 11. If I were just copy down the information, it said that we had 13.5 grams for calcium. Oxygen is 10.8 grams, and then hydrogen is 0.675 grams. So step one, again, is to convert each of these to number of moles, just using molar mass. So I'm going to need my periodic table handy and my calculator. And I'm looking again, calcium molar mass 40.08. So we need to make sure to put this on the bottom so that we can cancel out the mole. I'm going to go ahead and get all of these ready. I don't need to worry about diatomics because this is within a molecule. Okay, you only have to worry about diatomics if we're working with individual elements. So we would write 16.00 grams and 1 mole for oxygen. And then for hydrogen, we'd write 1.01 grams and 1 mole. Okay, so we want to go through the math and convert each one of those to how many moles that is. So this is something that we did before. And let's see if I can get a light on for you guys so you can maybe see my screen a little better. So 13.5 divided by 40.08. And I'm allowed 3 sig figs in this answer, so I'm going to put that here. So this would be 0.337 moles. Okay, 10.8 divided by 16.00. And this would be, with sig figs, 0.675 moles. Okay, and then this last number, which happens to be 0.675 anyway, divided by 1.01. And again, I'm allowed 3 sig figs, so this becomes 0.668 moles. All right, so now if I follow the next step, it says divide each mole value by the smallest number of moles calculated. So my smallest number is just 0.337 because I'm trying to get to, this is a ratio, but it's complicated to see and read. So I want to get to something that's easy for my brain to see. So I'm going to divide them all by the smallest number of moles whenever I went through that math. And remember, this is just telling me a ratio of the formula. Okay, so we already know the ratio, but we got to get it to a simple whole number. Okay, we already know mathematically that this number is going to be 1. So then these are going to be really, really close to similar numbers, right? So 0.675 divided by 0.337, and I end up with this 2.00. Okay, now we're not going to worry, and I'll show you why we don't worry about sig figs at this point, because we're going to round it anyway, right? Remember that last part of the direction? This is 1.98. So last part of step 3 says round to the nearest whole number. Okay, well, this is 1, this is 2, and this, that is so darn close to 2, we call it 2. Then the last step, we want to apply it to our empirical formula. So empirical, simplest whole number ratio. So Ca, I only had 1 of those. Oxygen, we would say 2. And hydrogen, we would say 2. So we would write it like this, okay, that this is what we're getting for an empirical formula for this particular molecule. We have no idea if this is also the molecular formula, but we know for sure this is the simplest ratio of all these elements that are found in this compound. Okay, so that gets you started. You could do the problems that go with this in your packet, and then, like always, check the answers. We will get those to you. And then tomorrow we will start with molecular formula talk. Okay, hope you're doing well.